So we can start now. So we're looking at number 2, electrolysis of brine using platinum electrode. Like I said, brine is a solution of sodium chloride, specifically concentrated sodium chloride solution. That is what brine is. So then again, take note of this platinum electrode. That means the electrode used for this electrolysis is an inert electrode. Sometimes you could also see electrolysis of brine using graphite electrode. It's also an example of inert, or carbon electrode. They are all possible for this case. Then, having said the solution is a concentrated sodium chloride, what we are going to look at now is ionization of the solution. So we have NaCl, which is sodium chloride aqueous. I also have water. Sodium chloride will ionize to give you sodium ion and a chloride ion, all aqueous. Similarly, you have hydrogen ion and hydroxyl ion, aqueous. So this is what you will get. Then the ions present are, so what are the ions present, madam?
We have sodium ion,
Okay,
chloride
sodium.
ion.
Okay, sodium.
Hydrogen ion and hydroxyl ion.
Okay, perfect. Thank you very much. Now, if we have these ions present, then we can now say at the cathode. So remember, what we are talking about is brine, concentrated sodium chloride. So since it is a concentrated sodium chloride, that means my concentration of sodium ion is higher than hydrogen ion. Likewise, chloride ion is higher than hydroxyl ion. Now, we'll now come to at the cathode. Remember those factors. Now, concentration is going to come into play here. Any question, madam?
No, sir.
Okay. Now,
go ahead.
Okay, at the cathode, we have sodium ion and hydrogen ion. So which of them do you think will be preferentially discharged? Is this sodium or hydrogen ion?
Hydrogen ion.
Okay. Hydrogen ion will be preferentially discharged, even though the concentration of sodium ion is higher because of the distance between them in the electrochemical series. Also, you already know this.
Yeah, than the
Yes, since it's hydrogen ion, I'll be adding hydrogen gas. Then this equation is not balanced like I did previously. You put 2 here and put 2 electrons here, and then to balance your equation. I hope this is well taken, madam. Then we'll now go to at the anode. Then for the anode now, which anion is preferentially discharged, hydroxyl or chloride ion?
Hydroxyl. Okay, the concentration of the chloride ion is higher here.
Yes. So which of them will be preferentially discharged?
Will be preferentially discharged.
Madam, come again. Which of them will you say, please? Is it hydroxyl or chloride?
Hydroxyl.
Okay. Hydroxyl ion wouldn't be discharged.
Okay.
Because if you check the distance between hydroxyl and chloride ion, they are not that far apart. So because a chloride ion has a higher concentration, the product at the anode now will be chlorine. The chloride ion will be preferentially discharged because it is a concentrated solution. So I will now have Cl, going to give me Cl to the gas, then aqueous gas, and you put your 2 electrons here and put 2 in front of this. I hope this is taken, madam.
It's taken. Thank you.
Yes. Okay. So now we have to write. Can I clean this first part?
Yes, sir.
Okay, so next is to write the overall equation. Unlike the previous ones, the electrons are of the same charge, so there's no need multiplying anything, just to cancel out. So we now have overall equation gives you this, cancel out this. So I'll have 2 hydrogen ion aqueous, 2 chloride ion aqueous, gives me hydrogen gas and chlorine gas. If you have taught your students halogens in SS2, one of the members of the halogen is chlorine. And one of the ways we can produce chlorine industrially on a large scale is by the electrolysis of brine. This is where that idea came from. So,
okay.
So the products now, what you now write now is products. Please always tell your students to always know the products, and also to be able to write the equation at the cathode or at the anode. We call it anodic half equation and the cathode half equation. So products are the anode. The product at the anode is hydrogen gas. Sorry, chlorine gas. Anode, Cl2 gas. While at the cathode is hydrogen gas, both in the ratio of 1:1, or the volumes are 1:1. Any question, madam?
Taken.
Okay. Next, we'll look at again is what is the solution like at the end of the electrolysis. Remember, the dissociation was NaCl, giving me Na plus and Cl minus, and water giving me H plus and OH minus. Now, since my hydrogen ion has gone off and my chloride ion has gone off, so I'm left with sodium and then sodium ion and hydroxy ion. If both of them come together, it gives me sodium hydroxide.
Yes, sir.
So at the end of the electrolysis, the electrolyte becomes alkaline in nature due to the formation of sodium hydroxide.
Okay.
Yeah. And then the electrolyte has the ability now to turn red litmus paper blue, because base turns red litmus paper to blue.
Okay.
Yeah. So that is how it will look like. Now, if you want to draw the diagram, just so you, maybe just for drawing, if you want to draw the diagram of this, you have something like this. If this is plus, this is minus, and then the direction of flow, I explained this one yesterday, the current enters the electrolyte through the anode. And remember this acronym, panic. Positive is anode. So this is my anode, and this is my cathode. So current enters, you see the direction of flow here now, and it's leaving direction of flow like this. Now, if this is the electrolyte, which is my chloride aqueous. Remember, because we said brine, the product at the anode is what? Is it hydrogen gas or chlorine gas? The product at the anode.
Anode is chlorine gas.
Yeah, so you'll see bubbles coming from here. If you do it, you'll see bubbles. These bubbles tells me hydrogen gas is being deposited. Then for the cathode, you also see bubbles of oxygen, your hydrogen gas as well around this. Then the electrolyte now becomes or the concentration becomes alkaline in nature at the end of the electrolysis. So here now is, we can put here in brackets, the anode is chlorine gas, and here hydrogen gas. So let the student know what is the product at the anode and the cathode during the electrolysis of brine. That is what they should know. Let them also know how to write the equation at the cathode and at the anode, and also what becomes the concentration of the electrolyte at the end of the electrolysis. Any questions?
Okay.
Okay, so let's just look at one more example before, maybe one or two, then we'll now look at calculations under electrolysis.
Okay, sir.
So another example, this time around, I will use electrolysis of dilute NaCl. Electrolysis of dilute NaCl. To save my time, do you know what will be the product at the anode and at the cathode for this one, so that we'll just look at another example if this one is easy?
Pardon?
Electrolysis of dilute sodium chloride. What we just finished now was electrolysis of concentrated sodium chloride, which is brine. So now I want to look at electrolysis of dilute. So to save time, this is more or less like a straightforward thing. You can even note this already. The product at the anode and cathode will be what, madam?
At the cathode, you have your hydrogen gas.
Yes.
And at the end, you have your chlorine gas.
No, this time around will not be chlorine gas because it is dilute.
Okay.
Since it's dilute, that means the water, which is your solvent, is higher than the solute. So which means concentration of OH is higher.
Is higher, yeah,
than your Cl. And OH is lower than Cl. So obviously OH will come out, leaving the Cl behind. Is it taken?
Yes, sir.
Okay, so maybe let's just quickly run through it. So this will be NaCl aqueous, giving me Na plus Cl minus. H2O will give me H plus and OH minus. Then at the cathode, I should have hydrogen gas, but just like you said, which is very correct. H2 aqueous plus 2 electron gives you hydrogen gas. This is what you will get at the cathode.
Okay.
Then at the anode now, at the anode is where the little challenge comes in, where students used to confuse it a little bit. So let them know, because it is dilute, concentration of OH is higher than Cl, hence hydroxy ion comes out. So the product now will be OH as against Cl for concentrated.
Okay.
So that's just a little difference. Yeah, and whenever OH comes there, I've said that before, your product will be water, oxygen gas. Then to balance your equation, you put 4 here and put 4 electron here. Any question?
No, sir.
Okay, now again, let's go further a little bit. Now, this is different. The charge here is 2, the charge here is 4. So I will multiply this by 2 and this by 1. So that still remains. Yeah, I will now have 4H plus 4 electron, 2H2 gas. So the products at the cathode and at the anode are hydrogen and oxygen gas, respectively, in the ratio of 2 to 1. Is that taken? The products at the cathode and at the anode are hydrogen gas and oxygen gas, in the ratio of 2 to 1, respectively. So if you care to write the overall equation, can I clean this?
Yes, sir.
Okay. So for the overall equation now, can you simply tell me what we're going to get for the overall equation? Overall equation. Overall equation.
Overall equation
of this electrolysis, this example now.
okay. It should be hydrogen plus hydrogen.
4H plus aqueous, 4OH aqueous gives you 2H2O gas, liquid rather, O2 gas, and 2H2 gas. So this is what you will get as your overall equation. Then,
okay,
what happens to the electrolyte at the end of the electrolysis? Since hydrogen was off and OH was also off, the concentration of the sodium chloride increases. That is what happens to the electrolyte at the end of the electrolysis, because I'll be left with sodium and Cl. So the concentration increases.
okay.
I think this is well taken. So let's look at another example. Then we can now begin to look at calculations on electrolysis, like I said. Electrolysis of, can I clean this, madam?
Yes,
Those
sir.
just coming in, sorry for that network glitch. It was just one of those situations. So I hope my apologies are accepted for those who were just logged out at that time.
Well, it's accepted. It's accepted.
Okay, thank you very much.
You know, it's not beyond our control. I wish there's something we can do about this network situation in this our country.
Exactly, sir. For the first lecture, I think I've been able to, I will generate the link to the Google Drive and I will put it on the platform. So for those who are not, and even the beginning of this one, I'll do the same thing as well. So that the file size is quite large. Let's what we can
That would be great. That would be great.
So let's move on now. Please, these aspects now, which I'm about to do, questions under electrolysis is mostly acidified water or copper 2 tetraoxosulfate 6. This one mostly comes in. So next we'll look at now is electrolysis. I'm going to do it side by side to save time. Electrolysis of CuSO4. I'm also going to do electrolysis of CuSO4. Both of them now, I'll use this one using platinum electrode. And on this end, using copper electrode.
Copper electrode.
So we'll be doing it side by side to save time. Electrolysis of, this is called copper 2 tetraoxosulfate 6. Using platinum, or sometimes I can also say using graphite electrode or using carbon electrode, also applicable for this. Then this is electrolysis of CuSO4 using copper electrode. Let's quickly ionize. SO4, H2O. SO4, H2O.
That's true.
We'll be having the same thing for both. So if I don't write this because of the space, you could as well just write it. This will give me Cu 2 plus, SO4 2 minus, H plus, and OH. So we see the same thing here as well. Put the state of matter all aqueous. Ions present, you can as well just list the ions present. They are the same thing. Then we can now come here as the cathode. As the cathode. So for the cathode, we have copper and hydrogen. The same thing here too. Yes, question. Is that a question or precious? So as the cathode, can anybody tell me what will be the ion that will be preferentially discharged?
Copper 2 ion.
Okay. Why do you say so, please? Oh, no, maybe it's a guesswork. So you should be able to tell your students so that let them understand the reason. Can you just tell us just briefly why copper 2 ion, not hydrogen ion?
It's lower in the electrochemical series.
Okay, thank you.
Displace hydrogen in the electrochemical series. That's correct.
Okay, okay. Displaces hydrogen in the electrochemical series. The one lower displaces the one higher in the electrochemical series. So, thank you very much. If you are close by, I will have given you a bottle of malt, or you are far up. So, okay. Now on the lighter note, so we have copper 2 ion, Cu2 plus. This dissociates to give us Cu. Let them know this is aqueous solid. Then you put here 2 electrons to balance the charge. Repeat the same thing for electrolysis of copper 2 that using copper electrode. The same equation is applicable here too. 2 plus gives you 2. Then at the anode now, at the anode. Please also note this. It is important that we do this one with our students in class. It's very simple. We can do it. I did it with my students, and I always do it with them every year. Copper 2 tetraodosulfate 6 is always, at least virtually almost all the labs have it. If you dissolve it in water, it will give you a blue solution. What you just do is tell the students, or if you can provide it, why not? Just this microphone batteries. Get one. Then for your electrode, you can use pencil, your normal HB pencil. Use that as the electrode. I will draw it how it should be, the setup should look like, and you do this with them in class. Once you do this, they're always excited saying this.
Okay.
So for the anode, instead of SO4, hydroxy ion is discharged. So I should have OH minus. As usual, my product is water, oxygen gas, 4 electrons, 4 electrons. So this is what you should get for electrolysis of CuSO for using platinum electrode. Any question? I will come to this first. Let's finish up with this. Now note this. If I check very well, this is off. Is that true? Is the hydrogen off or the copper?
That's all.
Okay. So for this, what is being removed here now at the end is copper is off. Then OH is also off. That is if you are using platinum electrode. So what you will now write here is product at the cathode, copper, at the anode, oxygen gas. Then you can always balance your equation here, multiply this by 2, put 2 in front of this, 4, and put 2 here. So copper is deposited. So if you do this, like I said, with the students, you will see deposit of copper at the tip of the pencil, which you are using for the serving as the electrode. You do this with them in class. You will see brown deposit of copper at the tip of the pencil. Then for the anode, your product is oxygen gas. Can I continue?
Yes, sir.
Okay. Now, the next thing we'll look at now is still on this, is at the end of the electrolysis, what happens? The initial color is blue. And that initial color, which is blue, is as a result of the copper, which is present. So since copper is being deposited, the color gradually fades. So the initial, what you will now write there is at the end of the solution or at the end of the electrolysis, the initial blue color of the solution gradually turns colorless. Then, as it turns colorless, I'm left with hydrogen and this. This will give me H2SO4. So the electrolyte also becomes acidic, having the ability to turn blue litmus paper red. So that is what you will get for this. The initial color fades off, copper is deposited at the cathode, oxygen gas at the anode. The electrolyte becomes acidic due to the formation of H2SO4. So that is that for this platinum electrode. The next one is copper electrode. Now, remember, copper electrode is a very good example of a reactive electrode. And because it is a reactive electrode, the copper material itself will want to be deposited or will want to be discharged. Just like you telling students, when in my school, I tell students, go and buy something for me in the canteen. They'll be telling me, okay, what is my commission in the process? Or okay, buy one for me first before I will go. They always want to get something in return. So the copper here now is also going to take part in this reaction. So instead of having OH or SO4 being discharged at the anode, none of this will be discharged. Are we on the same page? Remember this acronym again, cryo. What happens at the anode is oxidation. So copper, it will not be the opposite of this equation. That's what you write here. It's always very simple. Carry your product, put it here. And take this one this way on the other side. So that is what you will get for the anode. So in this electrolysis of this one, it's more or less like a continuous circle. The copper is leaving and coming in. So what happens is that at the cathode, copper is deposited, and at the anode, copper is oxidized. So the size of the cathode increases in mass, while the size of the anode reduces in size. If that is taken. Then at the end of the electrolysis, the initial blue color of the solution still remains because the copper which was responsible for that blue color is still in the solution. So the concentration remains the same. Any question?
Yes, sir, there is a question.
Okay, sir.
Like you just said, that at the cathode, that is copper, the size of the copper increases.
Yes. For which of them? Is it copper electrode?
Copper electrode, sir.
Yes.
That the size increases.
Yes.
Then at the anode, the copper is still remain present.
No, the copper, the size of the anode now will reduce because the copper, which is the material which is used to make the anode itself, will be oxidized instead of any of these coming out. Because what happens at the anode is oxidation. So the size of the size of this anode will reduce. Then the blue color still remains the same.
The same intact.
Yes, the blue color still remains the same. Any other question?
And the solution becomes acidic or basic.
Good.
Or neutral.
Since the solution becomes neutral because the situation still remains the same. Is that taken? Or is there any objection? If you have any objection, let's bring it up and let's see if we can all iron it out. If there's any area that is not so clear.
think it's clear, sir. I don't know for.
Okay, so I can move on. I'm left with 8 minutes to go. I think this should be the summary of everything on electrolysis. So let the student know this. This one is very critical. I would have loved to draw the diagram of this particular one, but since I've already explained it already, there's no need. All you just need to know is that for your anode, now, if for example, this is the cathode, you will see there's a deposit of copper around it. Then for the anode material, the size will reduce. You see gradually shrinking in size, telling me that. So that's the only thing that's the difference. Then if you have to draw this one, the diagram is that you will see deposit of copper here, and you will see bubbles on this other side. This bubble signifies oxygen gas.
This gas being evolved.
Yeah, it's being evolved. So that's the little difference here. Then, like I said, I don't know if we can still look at electrolysis, that is calculation aspect of it. I'm left with 8 minutes to go. And would you suggest we'll come back after 10 minutes to just look at 2 examples or 3 examples, or we'll leave it for another day, maybe tomorrow or next? Let's have a general consensus so that you don't look as if I'm imposing myself on anybody or taking your time. If we all agree, we'll leave it for tomorrow, and then or some other time.
My humble suggestion is that we just wrap it up today and think of something else tomorrow instead of postponing or procrastinating for when tomorrow will come.
Okay, if you have to round it, thank you for that. But if you have to round it up, we'll have to come back in the next 10 minutes because this session ends in about 5 minutes time or less than 5 minutes. Then if we have to come back in the next 10 minutes, I will crave your indulgence if possible. Maybe you get a calculator handy, or you can use your phone as a means of calculator, so that the next aspect is basically calculation. And this is one area that some persons have little challenge as far as solving the calculation aspect is concerned. So it would be nice we just go 2 or 3 examples. Most JAM questions are on calculation aspect of electrolysis. So I think I can stop here. We'll convene again with calculations on electrolysis.
Sorry, sir. Thank you very much. I think we're enjoying the class. Though I came in late in the second half, but
I will record. It's on record. The class is on record.
I hope I will get through it.
Yes, sir, you will.
Thank you.
That is great.